For the Pythagorean theorem, the formula is a squared plus b squared is equal to c squared. And c is always the side opposite the right angle, the hypotenuse. So one example is a right triangle that has side lengths 3, 4, and 5. The formula works that if we square these legs and add them together, it'll be equivalent to the hypotenuse squared. So 9 plus 16 equals 25. Everything checks out. To figure out if it's possible to make a triangle with 3 different side lengths, you can add together the 2 smaller ones and see if their sum is bigger than the third. If so, it's possible to be a triangle. If not, then it's not. An example would be something like side lengths of 3 and 7. If you add those together, it's bigger than 6. This could possibly make a triangle. 3 and 3 are equal to 6, so it's not possible because it has to be bigger than. And 3 and 2 are less than 6, so that triangle would also not be possible. A 45-45-90 triangle is a special type of right triangle where these two interior angles are both 45 degrees. So it's also an isosceles triangle, and that means that these legs have the same length, and the side that is opposite the hypotenuse is going to be whatever x is multiplied by the square root of 2. So for example, these are both 45-45-90 triangles. If one of my legs is 3, that means the other leg is also going to be 3. And to figure out the hypotenuse, I'm going to multiply by the square root of 2. And it's just that. If I'm given the hypotenuse, I have to divide by the square root of 2 to figure out that leg, which involves rationalizing the denominator. And that means I can't have a square root on the bottom of the fraction. So I multiply by a different version of 1 that will effectively cancel this out. Because the square root of 2 times itself is going to give us 2. Then I can simplify. 12 divided by 2 is just 6. So 6 root 2 would be the leg. That would show up here and here. A 30-60-90 triangle is another special type of right triangle. And if we go across from the hypotenuse, 2x. If we go across from the 30 degrees, that is x. And if we go across from 60 degrees, we get x root 3. This ratio between those side lengths is always true. So let's look at 3 different scenarios. With this triangle, I have to consider the 30, the 60, and the 90. Across from 30 is always going to be x. Across from 90 is always going to be 2x. Across from 60 is x root 3. So across from 90 here, I know, is 8. And that means that 2x is equal to 8. If I wanted to solve for a single x, I could just divide both sides by 2. And I would get that x is equal to 4. And if x is equal to 4, I can figure out x root 3 just by multiplying by root 3. So this becomes 4 root 3. And that's how I find my respective side lengths. Here's a different example. This time I'm given the one across from 60. So I'll start off the same, remembering what each of these equal. And here, 4 is equal to x root 3. So if I want to figure out what x is all by itself, I'm going to have to divide by square root of 3. So once I solve and rationalize and, well, I can't simplify, this tells me what x is. My actual length across from 60 is 4, but if I solve for x, it's 4 root 3 divided by 3. So that's going to go here for 30. I'm going to double it for across from 90. So the last example, this time I'm given across from 30, which is probably the easiest case because that's just x is equal to 4. So this becomes 4 root 3 and this becomes 8. And I'm done. So usually we use the Pythagorean theorem to solve for a missing leg or a hypotenuse of a triangle that we already know is a right triangle. But we can also use this theorem to determine what type of triangle we're looking at. If we consider A and B to be the shorter two segments, and we square them and add them together, if they're bigger than c squared, then the triangle is actually acute. If they're equal to c squared, we're looking at a right triangle, and if they're less than c squared, it's an obtuse triangle. So let's consider some different possible side lengths to see what these would look like. If I took 4 squared plus 5 squared, that's 16 plus 25, which is 41, which is bigger than 6 squared, 36. Therefore, we're looking at an acute triangle. If I took 3 squared plus 4 squared, it turns out it's the exact same thing as 25, 5 squared. 9 plus 16 is 25. So we're looking at a right triangle. If I took 7 squared plus 8 squared, that's going to be less than 144. 49 plus 64. That means it's an obtuse triangle. Given these two triangles, we're told that RQ and UT are the same length, and QS and TV are the same length. We're also told that angle QV, whatever it is, it's bigger than angle T, which means whatever's across from angle Q is bigger than whatever's across from angle T. So RS is bigger than UV. Number 3. Here's a 45, 45, 90 triangle. Since the hypotenuse is 3, to find the leg, I'm going to divide by the square root of 2, which means I have to rationalize the denominator, which means I end up with 3 root 2 over 2. So I can write that over here and over here for the two legs. For number 4, here's my diagram, and across from 90 is 6, which tells me that 6 is equal to 2x. So if I divide by 2 on both sides, I get x is equal to 3, which goes here across from 30. Since x is 3, the side across from 60 is going to be 3 root 3. To figure out number 5, I would take 7.5 and I'd add 4.5 and I'd compare that to 12.5. It turns out it's less than 12.5, so it's false that a triangle can have these side lengths. So for number 6, they want us to order the sides of triangle KLM from smallest to largest. So the first step is to figure out the third missing angle by subtracting the two known values from 180. That tells me that the missing angle is 75. So the shortest side is across from the smallest angle, which means KM is the shortest side. The next one is across from 68, KL. And the largest one is across from 75, ML. For number 7, I have to use both triangles here, and I'm matching up 37 with 32. Which one's bigger? 37 is. And that means that 8 is bigger than 2x minus 12. So that's my setup, and I add 12 to both sides. I get that 20 is bigger than 2x when I divide both sides by 2. 10 is bigger than x, or x is less than 10. Now let's assume that 2x minus 12 is bigger than 0. Then if we add 12 to both sides, we get that 2x is bigger than 12. And when we divide both sides by 2, we get that x is bigger than 6. If I want to put these two together, I know that x has to be somewhere in between 6 and 10. Number 8, there are two possibilities. There are side lengths 2 and 5, and then a third one that's the biggest of the three. Or there's a possibility that we have 2 and x, and 5 is the biggest of the three. So we do each inequality separate, and then we put them together. On the left, we write that 2 plus 5 has to be bigger than x, and over here, 2 plus x has to be bigger than 5. So x is less than 7, but greater than 3. For number 9, I drew a right triangle. I labeled the hypotenuse as 26, and I labeled one of the legs as 10. This tells me that 26 squared is equal to 10 squared plus b squared. If I was looking to enter this into my calculator directly, I would take the square root of 26 squared minus 10 squared. Since we know the hypotenuse, we can subtract. And this value, it turns out, is just 24. And as to whether this is a Pythagorean triple, yes it is, because a squared plus b squared does equal c squared, and they're all whole numbers. 10 squared plus 24 squared equals 26 squared. For number 10, we draw a right triangle with the legs 3 and 5. Since the hypotenuse is missing, we're going to take the square root of these two numbers added together. So if I combine those, I'm looking at the square root of 34, which is something like 5.8, meaning this is not a Pythagorean triple because the hypotenuse is not a whole number. So for 11, this is the ramp coming out of the back of this truck that is 33 inches tall. Since I know the hypotenuse, I can take the square root of 65 squared minus 33 squared in the calculator. That tells me this missing distance is 56 inches. For number 12, I'm going to add together the two smallest ones and see how it compares to the largest one, all of those numbers squared. Since 193 is less than 256, this is an obtuse triangle. For 13, here's my 45, 45, 90 triangle. If a leg is 3 root 2, then the other leg is also 3 root 2. And to get to my hypotenuse, I multiply by the square root of 2. So I get root 2 times root 2, which gives me 3 times 2, which just means it's 6. 14, here's my 30, 60, 90. The longer leg is 5 root 3. So if I'm looking at 30, 60, 90, that means that 60 was the 5 root 3. And if I want to get to 30, I divide by root 3. So I just get 5. And then if I want to get to 90, I double that, and it's 10. The length of the hypotenuse is 10. So for 15, I'm looking for this pattern. And the first one does fit it. That checks out. The second one also fits. The third one, if I was to take 5 halves and double it, I'd have 10 halves, which is 5, so this one doesn't work. This one checks out. And if I took 4 root 3 times root 3, I would get 12. There we go.